Good evening, ladies and gentlemen. How's that? Is that volume okay? Okay. So, welcome to this evening's seminar. Before I get going, there's a few housekeeping things just to mention. We'll basically have about a 40-minute session, then we'll have a 20-minute break or a 15-minute break. There's tea and coffee outside and biscuits. There is 1 teaspoon, which I've brought with us because it seems that there's an inverse relationship between the number of teaspoons and the luxuriousness of the research facility. So there is no teaspoons in IMAS on the ground floor, as I've been told. Second is that the facilities are just down here on the left for anyone who hasn't been in the building before. The seminars are being brought to you supported by Wood Solutions. So Wood Solutions is the marketing arm of Forest Wood Products Australia, and we provide basically support services and information services on Wood Solutions' behalf in Tasmania. We also provide it on the Tasmanian Timber Promotion Board's behalf. So if you ring either organisation and you want technical information, then oftentimes it'll come to us. If not directly to me, well, not generally directly to me, but to a colleague who then handles most of the easy ones, and he sends the hard ones to me to handle. And when we make up an answer, basically. Okay, so this evening's talk is about timber in decks, balconies and landscapes. And this is the second of 3 seminars. The first seminar we had Professor Christoph Sigritz from the Berner Fachschule, which is the University of Applied Science in Bern in Swiss. And he talked about a whole range of things we can't do in Tasmania, basically, but which we'd like to do. So in that way, it was quite an inspirational piece. He showed us many things that for them are now quite ordinary and for us are still quite difficult, but hopefully will become more regular and more ordinary as we move along. This one's a bit different. This one is much more technically focused, and it's about stuff you can do now and ways that we want to be able to do them better than we might have been doing them in the past. So it's a way of maintaining technical skill. The third seminar is on cladding, which will be, I think, in a month's time. I just do them. I can never remember the dates until the week before. And so in that one, we'll hopefully mix the two. We'll try and get a range of things that are quite inspirational from a European and American sense, and at the same time deal with some of the technical details of way you can approach cladding with different ranges of timber systems for basically building in envelopes. Okay, so I'm happy to take, if I say anything too contentious, I'm happy to take questions along the way. Otherwise, we'll have a question session at the end. So in effect, we'll have, as I said, we'll have one session, we'll have a break, and then a second. The first person out to the tea area is responsible for opening up the packets of biscuits. So there you go. Because if I'm looking a bit dishevelled this evening, I've just got down from the Midland Highway and there's stops, and anyone who's driven the Midland Highway in the last 3 years knows that there's stops and starts all the way along the way. And tonight there was lots of stops and starts. So the major technical resource that backs up most of what's in this seminar is in this guide, the Timber Service Life Design Guide number 5, or the Design Guide number 5, which is called Timber Service Life Design. It's quite an old guide, it's about 10 years old, but it's one of the more advanced guides in terms of the organisation of its. So you'll have to open the chocolate biscuits. Absolutely. Okay. It's one of the most advanced guides. So about a decade ago, or maybe even a bit longer, Forest Wood Products Australia supported a large research project with Timber Queensland and CSIRO to try and develop an engineering base to durability design. So they wanted to do a whole range of technical work on how quickly things decayed, how varied different sites were from one site to another around the country, how that impacted things like decay rates, above ground decay rates in the ground, corrosion rates for metals, etc. So all of that work was put both into a guide and into a piece of software. So there is on the Forest and Wood Products Australia website a small piece of software that only runs on a PC that you can download, and you can put in your application, where it is, how exposed you believe that will be, the species that you're looking to use, and it will give you an estimated service life for those components. So it may indicate then that certain parts are going to break before other bits, and you can reinforce particular components as you want. So that information is embedded in the presentation, but if I tried to do all that detail tonight, you'd all be asleep and I won't get home. So that's one thing that is then underpins some of the discussion. The other things that underpin the discussion is that there's been a lot of people being killed by decks and balconies, balcony collapses particularly, across the last 5 to 10 years. So it's currently one of the largest causes of domestic building related death around Australia. So all state governments have in the last 10 years issued guides on how to look after balconies, what to look for, how to inspect them. So some of the things in the presentation actually draw from those, and we've got at the back, we're going to have a look through some of the guidance that they provide in terms of things you should check and look out for. In part, that's because many of you are professionals, and you may actually be called out to do building inspections, or at least building renovations, and knowing what it is that may be problematic before a renovation or as part of building inspection then becomes quite important, because you know what to avoid, or B, what to advise your client on fixing if you think that there's a problem. Okay, so what we're going to look at is, I've got a couple of European projects, or two European, one American project that just shows you some of the things that people are doing in various parts of the world. We'll then look at design and detailing for durability, and it'll have a lot less pictures in it. We'll then look at maintenance and inspection. But in between the first two and the third, we'll have a break before we come back to discuss maintenance and inspection regimes. Okay, so this is one of the three buildings, but just have a quick look at. This is a memorial building designed by an architect and an artist working in combination, and it's on the Bering Sea in Norway. And it's a memorial to women who were burned as witches. Interestingly, it seemed it was very popular to burn witches in this area between the late 1600s and the early 1800s. And so this building then has been established as a memorial to those people. So there's a number of different elements involved. There is, as we'll see on the initial slide, a long walkway which takes you out to the installation, and inside is a very long black timber floor and an enclosed space with lots of small windows that are there to give you an impression of what building and living in that sort of part of the world must have been like at that time. On the outside, you then have this quite interesting installation put in right next to the ocean. So it's a major landscape installation made with thin timbers, and it's again in quite an aggressive environment in terms of the fixings and fittings that have gone into the building. This is a much more fun thing. This one's in Helsinki, and it's a public sauna. So in this part of Helsinki was an old industrial area next to the sea, an old ports industrial setting. And so parts of those old buildings have been pulled down, and the city is re-establishing community life next to the ocean. And they're proposing sports that out here in the bay be used for water sports. So at the same time, they were encouraging people to re-adopt the old traditions of communal saunas rather than everyone separating and having individual saunas. I think there's some crazy statistic is that there's one sauna for every 1.5 people in the country. So inside the building are some public saunas. Outside of the building has then been converted into what is an outdoor grandstand for watching water sports in the future, plus an area for people to come. There's cafes there and walkways and promenades. Now, all of this is made out of the local softwoods, but it's all been heat treated. So heat treatment, as we'll discuss it in a little bit more detail later on, is a means by which you heat up the wood. The heating process drives out some of the materials in the wood, depending on how much you heat it up, and that makes it much less attractive to fungi to grow. So it reduces the decay rate in the material quite a lot. The unfortunate thing it also does is it reduces the strength characteristics of the material. So a heat-treated board may lose 30% of its bending strength and become much more brittle than an unheated one. So what we might find if we got out the details of this, well, we might find that these elements are actually quite robust. To make up for the loss of strength, they've gone up in size. So, but you do then have the deck, and you have then this landscaping element that people can walk up and also sit on. Now, I don't have pictures of inside, but we do have some of the outside. So this is it actually being used for a little festival. People sitting on it, using it as a recreational area on a warm day, probably faces south, so that it faces into the sun, and people go up there and sun themselves. This is a much more robust US example of, again, the change of an old industrial area into something that's more residential and then allows for people to have greater interaction with the communities. So this is an old industrial area in New York, and there was a railway line and a road that ran across in between the buildings, and all of that's been decommissioned. Parts of it have been cut off so that only certain sections of it now exist. And they've been converted into gardens and walks. So in approaching the garden and walk, they've then made this large timber ramp which takes you from street level up onto the railway level and then provides a whole range of seating locations for people to run things as well as to enable people to get from the bottom to the top. You've also got then decks areas here which incorporates a whole range of seats, and I think it's worth having a look at those in detail. So this is a combination of seats and lights which are effectively embedded into the deck. So they come out of the deck, they form a seat, there's lights underneath, and there are other services then that have also been positioned under them, and they've been arranged as a sculptural object. This material is obviously all dry, milled board because it all has nice clean edges and straight sides. If it was unseasoned material, it wouldn't look so nice and neat and clean and tidy. But they're really quite interesting little pieces. There's obviously services then underneath the grids that they can use with the seats. Okay, so if we look now for a bit of design and detailing for durability, if you want to start to design things like this, how do we start to approach it in Australia? The first thing is that anything we want to build is governed by the NCC, the National Construction Code. And it governs the design of decks and balconies and any similar landscape structures you're going to put in. There are significant requirements then for structural adequacy and provisions of things like handrails and safety on decks and balconies. For commercial structures, it's AS 1720. For residential structures, it's designed to AS 1684. Now, any of the deck things that we want to talk about in terms of element sizing, minimum element sizing, then it's all going to come from these two codes. So if it's in a domestic situation, AS 1684 is where you look up the minimum sizes for spans and out of the tables, depending upon the grade of timber and its treatment. And for commercial structures, it needs to be calculated to satisfy the design loads of those structures. There's one thing to notice, though, is that the NCC's durability requirements are generally pretty low. They don't have a specific design service life for anything. There is a guidance document that is, I think, now over 8 to 9 years old, which only gives you guidance. And it doesn't give you something that you can then specifically design to. It doesn't give you it doesn't prohibit certain practices, which may not be necessarily sensible. There's a whole range then of various acts which influence access and equity requirements for people to get onto these facilities. And in the design sense, I'm not necessarily going to cover those outside of saying, well, there are examples overseas or many examples in Australia of where you've got good design in these facets. I want to look specifically at how you're actually going to design a timber one that's durable and to get it to perform over time by selecting the right materials, by joining them the right way, by approaching the design in a particular manner. So there's a four-point program. One is assess the hazard conditions. Then it's to match timber and connections with the hazards for the required service life. Then it's to design for performance and detail to minimise hazards, which actually means it lasts longer than bad design. And then lastly is to maintain the item. Now, it's always embarrassing for me to see really nice timber put in a spot where you know it's going to only have a service life of a very short period of time because of bad design. Not because there's a problem with the wood per se, it's just either put in the wrong spot or it's used in the wrong way. And that's something that's the designer's fault or problem, or the person who made the decision to put it there. It's not necessarily the wood's fault per se. Because if you make something out of radiata pine and you put it outside, you can't be surprised if it's going to break down in 3 or 4 years. You know, it's going to happen. It's just the nature of the beast. Okay, so if we look at the hazard conditions. Okay, so there's 3 sets of hazard conditions, things that influence what the actual hazard is. The first is the hazard class, which is a very, very broad brush approach to problems. The next is the hazard zone, which actually gives you a bit more discerning arrangement in terms of those hazards. And the next is the site's location and the surrounding conditions. So with wood design, there is 6 accepted hazard classes for applications. They range from H1, which is the least hazardous, through to H6, which is the most hazardous. H1 is like in here. It's like these tables, the cladding, the furniture, etc. H1 conditions, everything's away from moisture, it's got good airflow, it's unlikely to be a problem. H2 is basically something that's protected from the weather but may actually be in a wall. So there may be moisture conditions that are going to influence it. There might also be termites and bugs that want to get into it. H3 is outside above ground. So if we have a deck outside this wall and it's above the concrete and we have cladding out here, then that's all in H3 conditions. That's what it's known as. H4 is in-ground contact. So if I had a deck out here and it was sitting on the concrete, the material that's sitting on the concrete is H4, is in a H4 condition because there's water that comes up into it regularly. There's no ventilation around it. H6 is in ground contact where you've got extreme conditions or where you've got something that's really important. So if you've got a pole frame house, you're putting the poles down into the ground, that's a H6, that's a H5 condition. You don't want it to fail, so it's structurally important, and it's in the ground in an exposed location. H6 is then immersed in seawater. So we're particularly looking at between H2 and H4 in this seminar. That's what we're going to find with decks and landscaping arrangements. So how you differentiate these is that, I haven't got a stick. Up in here, H1. In the wall frame, on that back deck, H2. The deck's covered, so it's completely covered by a roof, so it's technically H2. Here where it's exposed to the weather, it's H3. So generally you draw a 30-degree line from any shelter, and whatever's inside that line or outside that line is regarded as H3. So the cladding on the outside of this is actually in a H2 condition. The cladding at the base of this one's in a H3. So it will actually get quite a completely different conditions. This is obviously in a H4. If we had one of these holding up a large portion of the building, then we'd class it as H5 and treat it accordingly because it becomes a critical object. So then we have hazard zones. So we've dealt with hazard classes in terms of where things are in the building, but it does make a big difference about where the building is. So obviously design in Cairns is different than design in the inner parts of Australia or design in Hobart. Very different conditions in each of those three locations. So if we look at this diagram here, we'll see that for above ground decay is that there's 4 zones been established, A through to D, with D being the most hazardous conditions. So obviously up in the northern parts of Australia, we're in the tropics where we get lots of rain very often with hot temperatures. It's a very, very good place for bugs and things to eat wood. As you move away from that and you get into colder areas, with colder areas, you do then move into the second most dangerous area, and that's Australia, that's Tasmania, Sydney, and around on the coast. Now, for us, the problem here is not so much temperature, but it's that we get a long winter where we don't get a lot of drying. So material stays wet for a long period of time, and it's the wet that makes the difference. Because fungi need water to grow, and fungi are what decay the wood. So if the wood is dry, it doesn't decay. Simple rule. The more likely a place is to be wet, then the more likely you're going to get something that's going to decay quickly. When we go into the ground, the situation's a little bit different. D is at the north, C is down to Canberra. We're in B, so it's not quite as bad as previously, and the central part of Australia is A. Now the central part of Australia means is that you don't have a lot of water and there's a lot of dry conditions. So the ground is dry, it's dry outside, which means the incidence of decay is much, much lower than somewhere in a similar location on the coast. So in Hobart or in Launceston, the two things we're concerned about is that we're going to be quite susceptible to decay above ground, and we're not quite as badly off decay in ground, but it's something we've got to be careful of at the same time. There's also a whole range of factors about the building, where it is, what side of the hill it's on, etc., which make a big difference. So anyone who's grown up in or lived around Tasmania knows that the south side, the north-facing slopes, or the south side of valleys, is generally a lot drier than the north faces of valleys, because the north face faces the south and the south side faces the north. So the north one gets the sun and it's much drier than the other one. So a building on this side of the valley is going to be a lot damper than this one. It's not going to get as much breeze, possibly also. So what you're going to find is that decay in this one could well be worse than that one. Or decay on one side of a building will be higher than the decay on the other side of the building. Similarly, if you get a lot more sun on the north side, the timber on that side is going to weather a lot more than the timber on the other side. So weathering means is that all your finishes are going to break down faster, and the timber's going to check and things on the surface more than the other side.
What about prevailing wind and rain?
Prevailing wind and rain does make a difference, but it's basically the moisture that you get in the surrounding atmosphere over time that makes a difference. So I don't mention it anywhere else, so I may as well do it here, is that fungi, which cause decay, need a moisture content in the wood of about 20%. And they need it regularly, otherwise they die off. So if you don't have moisture content over 20%, the fungi won't grow. If you only get it for 1 week a year, it's not going to decay something out. Okay, so hardwoods particularly are very slow at accepting moisture. The ambient moisture conditions in, say, anywhere around here, outside, exposed to the weather all the time, in the middle of winter will only be about 15%. In summer, it'll drop down to about 12. If you have a roof over it, it stays about 12 or 13 the whole year, right? Because for a whole range of reasons. But anyway, generally, if you've got a wood deck that's well ventilated, even outside exposed, decay won't necessarily be a problem unless you actually stack things in such a way that the water gets underneath and comes in and stays in there all the time, is trapped. So the whole aim of the game, as we'll talk about later, is getting good ventilation. So if you can keep it dry, it will last 2 or 3 times longer than if you let it get wet, or let it stay wet. No? Getting wet is not a problem per se, it's when it stays wet that's a problem. Okay, so if we face things the wrong way, or we know we've got a damp side of the site, then we want to make sure that we're accommodating that in the things that we select. So obviously, in this example here, the proximity of the wall and the shade over the top, etc., is obviously going to mean that this is a much more sheltered location than if this deck was out on its own and facing the sun all the time. Now that might be good for us, or it might be bad for us, depending upon the time of year and where that building is. This is probably, not so much that one, not so much this one, but certainly this one is the largest source of complaint and failure in decks in Sydney and Melbourne. So people they'll want to make a deck, they'll see it on, Better Homes and Gardens, here's a deck, this is what we've got to do. So they buy some pine, treated pine, it's got to be good. They pack it on the ground, they put it on some cement, level it all off. Then they will put another batten across, put boards over the top, and then wonder why in 5 years' time the thing starts to break through. In part, the reason is they've made a swimming pool. And the swimming pool holds all the water in, and that then creates a perfect environment for fungi to grow. So all of the guidance in Sydney and Melbourne that they give out at the hardware stores is get it up off the ground, get it so that it ventilates. Even to the case where you dig down and make an airspace around the side and leave a space between the ground and drain it properly, if you want to get it. But that's obviously a problem, and this is obviously an issue with any timber structure, because all that, as you can see, is leading to decay there at the bottom. So the decay stops once you get that far away, though you might get mould on the surface, but the full decay will stop once you get it dry. Okay, so matching the hazard, matching the timber and the connections with the hazard is in your next deal. Okay, so there's a couple of things you've got to consider. One is the natural durability of the hardwood and the material, the treatment of the sapwood, and the selection of durable connections and fixings. Now, I'll just explain what the difference between hardwood and sapwood is. When a tree grows, it grows generally as a circle in plan, and the outside bit is living cells, and they transport water and nutrients from the leaves to the roots and back again. Okay, so it's a band of certain width. It varies. In hardwoods it's quite small, in pines it's quite big. Now, as it's moving those sugars and fluids up and down, it's got lots of starches in it. It's also, the cell structures are quite open because you want to move fluid up and down. So that stuff's called sapwood. The stuff called heartwood is the bit the tree doesn't need anymore to move fluids up and down, and it's the bit in the middle. So the tree pumps waste products from photosynthesis into those cells to toughen them up. And with hardwood, what that does is it changes the colour of it often. So if you get blackwood, which is really quite noticeable, if you get blackwood, the heartwood of blackwood is dark, but the sapwood is white or very, very pale. So if you get blackwood that's got a pale stripe and a dark bit, then that's the pale bit is the sapwood. Okay, so in hardwoods they're really quite easy to often very easy to tell. In pines it's much more difficult. Anyway, the key thing is that the heartwood has a natural durability that people have tested. The sapwood is full of starches and everything loves to eat it. So it's always regarded as a non-durable material. No matter what species it comes from, it's regarded as non-durable. It does, however, have an open cell structure, so you can get stuff into there. That's one key thing we'll come to in a minute. So we've got to treat the two differently. When I talk about durability classes, it's only the heartwood. It's not the sapwood. All right, so timber resists hazards through its natural durability, and that varies with species. So it's a characteristic of the genetics of the tree to how durable the wood is. Also, age plays a part. So an older tree the wood from an older tree is likely to be more durable than the wood from a younger tree, even though it's heartwood. Though no one's done the tests. It's just a suspicion. The difference between durability between heartwood and sapwood is actually quite significant. Okay, so, and also the structure of the cells makes a difference too, because certain bugs like the cells in particular timbers, and they can't lay their eggs in other timbers. So to be specific, hardwood have a large cell in them called a vessel cell, and our southern hardwoods tend to have big vessel cells, and there's a moth that has evolved to lay its egg in those cells, and then the larvae grows and eats the wood, the sapwood, around those pieces, and it can't do it with some others. So all the performances are listed in this standard, and they're all listed on the Wood Solutions website. So if you want to look up durability, it's on the wood solution site. So durability is given for in-ground contact, that means buried, and also outside above ground. And this is the result of long tests over 30 to 50 years. Okay, so things are then graded on a 1 to 4 scale, 1 being the best, 4 being the worst. So 1's highly durable, 2's durable, moderately durable and low durability. And this chart here is from research papers which actually give you the results of tests from a test site in Sydney of a species that's class 1, class 2, class 3, class 1 being the flattest, lasting the longest with the least decay, up to class 4, which has the most decay in the shortest period of time. So that the variability is quite significant. So all sapwoods class 4. So this gives you a table then of their life expectancy of each of those classes of material, depending upon where you put it. So if you've got in-ground, which is a H5 condition, with durability class 1 material, you're expecting greater than 25 years. And it might be significantly longer than 25 years. Coming down to class 4, where you've got between 0 and 5 years in-ground in a H5 condition. So outside in a deck, you might have 7 years getting from something that fits in this one, such as a Vic Ash, or even most of the Tas oak species will only last 7 to 10 years outside. Even in a deck, you'll find that they'll start to decay away. And it will increase up. Now, we did a big project down in the Ewan, the Geeston Forest and Heritage Centre, when I first moved to the state. And one thing we did is we put in celery top pine mileposts along the Arve Road out towards Terhune. And I didn't know anything about wood much at that stage, having come from Sydney where such things aren't discussed. And the local foresters said, look, we need to sap these things. So we need to sap the celery top poles. And I said, all right, well, I wasn't going to argue with them. They were going to do it anyway. So they sapped them. They cut the sap off with axes and adze, and then they shaped the signposts and they put them along the Arve Road. I was out there in March, so they've been in position now for almost 30 years. And all of those signposts, when you dig down into the ground, are all actually in pretty good condition. Now, the Arve Road is not a prime place for good. It's damp, it's cold, and it's regularly wet all the time. We put other posts, celery top pine posts, in the ground at the same time, which had the sapwood on, and all of them are now mulch. The reason being is that celery has this characteristic that if the bugs, the fungi, can attack the sapwood and establish themselves, they can then attack the heartwood. If you take the sapwood off, they cannot attack just the heartwood and establish. Does that make sense? I'm only putting that in because A, it shows me in a good light, but B also is that timber species are really variable in how they perform, and there is a lot of local knowledge that goes along with some of these things. So different things will perform in slightly different ways, but if you put a piece of sapwood and heartwood out at the same time, the decay in one will lead to the more rapid decay in the other. Yep.
With the celery top, can you distinguish between the sapwood and the heartwood easily?
Yeah, there's a slightly different tone to them. The sapwood is a paler colour. The inside slightly more honey coloured, slightly more honey coloured. So with a post you can, but in sawn timber I can't tell you if you can. Most sawn timber actually doesn't end up in a deck. They'll all end up in a painted siding or a cladding or in furniture. So celery is quite hard to lay your hands on now. Okay, so this gives you an example then of a deck that's probably of a durable species, but you can see here where decay is starting on the corner of the board, and that's due to that being sapwood, while the rest of it's probably heartwood. What's also, we can have that argument later about whether it's upside down. Groove up, groove down. So I've seen quite a number of cases. There's big decks in Launceston that are public decks where they've specified species, and you'll have a whole line of on the edges of boards where it's all decayed away and the other side hasn't. So it can be quite a prominent thing. Now, one thing you can do then to with species that are not very durable is you can treat them. So treating introduces chemicals either onto or into the wood, which then make it unappetizing for fungi as food. On the mainland, you've got to talk about fungi and termites, but here we don't have them yet. So we don't necessarily bring that up. Yet. I think they come with a fruit fly. So the target, now the thing is that with the treatment, is that the level of treatment is targeted at the hazard class. So if you get something treated to H4, then that's the situation that it's treated to go into. So a H4 treatment means is it's suitable in a H4 application or less. If you buy H3 treated material and put it in a H4 condition, then it's not going to last very long because it doesn't have enough chemical in there to keep the fungi out, given that you've put it in this really nice place to grow. So when you specify, you need to make sure you're specifying the right hazard class material, or if that's what you're buying at the hardware store from the suppliers. Now, there is no connection, direct connection, between a durability class and a treatment hazard class. Durability class exists independently of the hazard class of treatment, because I think I've got it coming up next. Oh no, I'll have it coming up in just a second. I will come back to that one, because this is why, is that you can't treat the heartwood of material reliably, or you haven't up till now. Some people believe now that you can, that there's certain things that they've developed that will take the stuff into the wood. There's other people who believe that that's all just marketing gop. We don't quite know yet. There hasn't been enough work done. So if you treat a piece of hardwood, then it will go into the outside material or it will go into the sapwood only. That's all it will do. So this post here, this bollard, is from a piece of telegraph pole that's been treated, fully treated, pressure treated, probably to H5 at Longford. Then it's been used as a bollard, and you can see that the bit that's this circle on the outside is still in reasonable condition. I mean, it's weathered, but it hasn't decayed. The bit in the middle has decayed. So the treatment has worked, but only from where it can get in, and that's only the sapwood. This is a pine log, and it looks like it's got all the way in, but it doesn't actually. It gets in part of the way. Sapwood and pine is quite broad, like there's a lot of sapwood on pines. So if you get a big pine section and you have it treated, that's likely what's happened. So this is out of material that was supplied to a local council. They asked us to test, so we broke a bit, and then we cut a sample off to see how far the penetration had gone. So this is actually the heartwood of the pine. So this has been taken out of a reasonable size log, but it's been cut into large sections. And you can see that that bit has no treatment at all. Yeah? So if you used it this way, and you put spikes or bridge decks or drill holes through in here, then all you're going to do is introduce water straight into that, and 5 years' time, all of this is going to be eaten out in the middle. So it's not doing any good. Okay, so I will give this is probably the only company plug I'll give tonight, is that I do know that the major softwood producer in the state only cuts and only treats section that are sapwood rich, which means they don't cut bits this big, they just won't supply it, and they'll specialise in making sure that this is the bit that goes into the mix and goes to the treatment plant. The bit that's likely to be in the middle goes into other framing. Yeah? So that's deliberate on their part, which means you can't get, if you specify this bit treated, you're taking the risk is that that's what you're getting. If you say, I actually want 220 by 35s or 220 by 35s, and you buy it, it'll be more expensive, but it's going to last about 4 times longer. Yeah. So, okay, so I think we won't deal with that. Okay, so if we're looking at timber outside, then if we've got a highly durable case, we're looking for something that's got a durability class 1 or 2. Now I'm looking about decks now outside in the sun, flat, where you're going to get a lot of water. You're looking at durability class 1 or 2 material. Now in this state, the only thing we have that's approaching that level is probably Johnston Eye that you can get from Terenius. I think Terenius occasionally cut it. I don't know anybody else who is. Johnston Eye has no durability figures. So if a surveyor wants them, then don't use it, because there's so little of it being around, it's never got into the cycles of durability testing, which haven't been done for 30 years. I mean, there hasn't been any durability testing done since this century, I think. So that's one. The other is silvertop ash, which is Eucalyptus zebrae, and that's only available from the northeast. That's the only place it grows. And there are some smaller millers up there who also then will cut and supply it. So if you want to see what it looks like, the deck over here that's in Sullivan's Cove near the crane, the old heritage crane, that's all done in zebrae. Okay, the decking is zebrae. The next is you want to treat it, and so you want to treat it to H3 or H4. You could potentially heat treat something, but heat treating something and then protecting you can use it like a graded piece of 20 mil, you're out for problems. If you want to heat treat something, you've got to allow that it's at least 30% weaker than the original section. So if you're going really oversize, you could probably do it with confidence. But if you're just doing it in a 20 mil or a 30 mil to get a 600 millimetre span, then I think you need to test some. The last is then a full paint system with flashing. Now I've put that in because I've seen the Europeans doing it. And this is an example of decks being prefabricated in a company in Germany with spruce, and each of the elements is completely coated with paint first, then it's assembled, and then they're putting this sheet metal flashing over the top, which is adhered onto the top of the timber in locations. So you still get, and then the decking goes on top of that and is clipped in. So I feel that also is that after they put it in, it then gets a top coat of paint. So that means then it's fully protected from the weather as long as the paint coating stays in place. There are a lot of verandas in Hobart and Launceston that are fully painted. A lot of veranda elements that are fully painted and are actually in reasonable condition if they've been continually painted for the life of the building. It's not this may be an acceptable solution, but
You can only do that if the client agrees to it as a performance
All right. If we look at the, all right, I'm happy to have a chat about that one. Okay, so the next we're after then is durable connections and fittings. So this requires consideration of potential corrosion when it's embedded in the timber, corrosion due to atmosphere, and then the material used in or protecting the connector and fixing, and the behaviour of the timber, behaviour of the fixing in the timber. So the Design Guide 5 then looks at hazard zones for material that's embedded in the wood, and in Tasmania we're in the most hazard-prone zone. So stuff in the wood will corrode in the wood more as regularly here as it will in parts of the Northern Territory. There's also coastal zones that then lead to corrosion due to airborne salts, and again, we're in the most hazard zone. So this zone E is the most hazardous for this condition. So in the guide, there's this table, which I'm not going to go through in detail, except to say that if you're in a condition where you've got close to water, then really you'll want to go to, if you can, to a stainless steel solution. If you're further away from the water, a hot dip galvanised or mechanically plated material may be adequate. Something that is a sheet metal piece made by Prider that's got a coating on the outside is not going to do in a situation where you're close to the water. It will not last, and it will corrode away. It will corrode away quite quickly. You will need better material and better conditions than that. These plated products and mild steel products are really for only indoor uses. Something's talking. So this gives you an indicator of fastener performance. Here's a veranda, standard sheet metal connectors, been nailed onto the edge, they're all corroding out. I had one of the people who came to the seminar last night had done an inspection of a veranda near the water up on the Tamar, and all of the connectors holding the joist to the building were all rotting out, all corroding, just like this. And so those sorts of things either have got to be avoided, or if you see them, they need to be replaced. This is a condition where you've got nails that are being pulled out of bits of wood. Most of you will have seen this in some point or other. Basically, it occurs because you've got a board. The board will be dry. When it dries, it shrinks. When it gets wet, the timber expands. It expands first at the top the most. It grips the nail. As then it grows in height, it pulls the nail up with it. Then when it dries, it lets it go. And it basically progresses that way unless the nail is spiraled and it's well put into the wood. So you will see cases where nails will be pulled out like that. Same thing happens with nail plates if you've got a truss that's outside and exposed to the weather. Even if the nail plate is protected, you'll find that the nail plates will pull themselves out over time. So they need also then to be fixed off with some screws to hold them in place and stop them being pulled out. Okay, design performance to minimise hazards. Okay, so a couple of things here. We want to design for a compliant, robust performance. We want to detail it to reduce the impacts of moisture. We want to understand what happens when it gets in sunlight, and I'll do with that more in the next seminar, which is weathering. And you want to protect from termites, which is something we don't have here yet. Okay, so this is the durability requirements in AS 1684, where structural timber members are in-ground contact or not protected from the weather exposure and associated moisture should be class 1 or 2 as appropriate, or should be adequately treated. There are requirements then for grade in terms of span of the decking members. And of course, this is only for domestic or residential buildings. They're graded by a visual appearance grade, but basically that deals then with the straightness of grain at the same time. So that's notionally allocated a structural grade, because most people will buy the stuff as an appearance grade. And there are specific requirements then for ways in which the material is fixed. And in AS 1684, all of it for decks covers about 5 pages, of which these tables are most of it. Okay, compliant performance also then means things like handrails. Is that this isn't compliant because the amount of play in the handrail is too much. That can be a problem from detailing, not necessarily from the detailing over time, not necessarily the initial installation. This, of course, looks marvellous. Your client might think it looks absolutely fantastic, but of course it's completely and utterly illegal because every child can climb over that and then fall over the edge. So it's a climbable structure. Okay, so one thing about the NCC, it establishes loads for decks and balconies, which is, I think, usually 2 kilopascals. In AS 1684. A lot of decks will then carry a lot of additional load that may not be apparent when things are first designed, such as additional pot plants, water features that people put on, furniture and the like, which can add a lot of load onto the site. And one thing that's consistent then with a lot of the deck failures is that the decks are carrying far, far more than the initial design load. So there's a case in New Zealand where there was a major fireworks display. Something like 16 people came out on a deck, which was not much bigger than, 3 or 4 times the size of this table. They were all out there watching the fireworks, and the whole thing just fell off the building. In that case, it was excessively loaded, but people do that. They don't necessarily think of that when they're all coming out to watch the fireworks display. Okay, so robust design allowances are then warranted. So conservative oversizing of elements is probably a good approach. So don't look at what the AS 1684 says is the minimum, go up a size. Look at very positive bearing of elements, and also then look at quite robust connections. So in one of these guides that have been prepared for the various state governments, probably the West Australian one is the most and best well illustrated. So this is looking at robust performance in terms of fixing, sizing, connecting of handrails to major elements, not connecting them to just the deck, where things are likely to move, where the load paths are too erratic, and so that you can get then material you're then getting handrails that can't shift and will perform well over time. So it recommends cleats like this, cleats like that, and not nailing it on the side or housing. And if you look at major projects, this is a major deck that was put in Canberra on Lake Burley Griffin. You've got steel connectors here, you've got recycled timber bearers underneath, and this had then a timber decking put straight across the top. You can see the large connectors there used. So you do end up with a robust connection. When you want to detail, then you want to detail to keep the timber dry, if you can, by using a roof or an eave. You want to exclude or shed water, and then you want to ensure that the wood can dry out if it gets wet. So the amount of water trapped into the surfaces, into the connections, is something you want to minimise as much as possible. So this is a detail out of the guide. This is from a Queensland example. where you've got a bearer, you've got a light flashing material underneath, and you've got decking boards put on the top. Now, you don't want to use a bitumen coating because the bitumen coating won't allow the timber to breathe out moisture if it comes in through the top. A looser material like this will give you a better performance. You want to get stuff out of the ground as much as you can to ensure that then you've got good air movement through positions, particularly in the ground. Also then, if you can detail it so that the decks, the cladding of the building actually goes past the deck. The deck then sits slightly spaced out from that cladding and then fixed back through into a support structure behind, so that the water can't get down into the building, but also can get past the deck, past between the deck and the cladding. So there's a number of instances. You'll see later on in the guidance that they give, the checklist is always to check to see whether the deck has been built and the cladding's then been built over the top of it, because that then creates a great spot for water to be redirected back into the middle where you can't inspect it and you can't see what's going on. And those fixings are the ones that go in a lot of the cases where you'll have these decks come away. Some more detailing. Top caps, details that allow handrails to meet balusters with airspace between and solid fixing locations, or there's a pretty rudimentary, cut there across the top and a clear finish put on to protect the end grain. I brought this one back basically to highlight that the fixings on this are not in line. They're spaced across the piece. Because they're spaced across the piece, the likelihood of the piece splitting along the line of where the nails are put, or the fixings are put in, is reduced. So that you're not actually making a split then in which water can get down through. So the fixings offset means that you don't encourage that split along the wood. Okay, so I'm happy to take some questions, or we can just head outside for a biscuit and a coffee. All right, ladies and gentlemen, thank you for coming back in. Quickly, I just want to cover maintenance and inspection before we take any more questions. So obviously, as you want to inspect regularly, you want to recoat coatings before they oxidise. 2 years for clear coatings outside, 2 years to 3 years is basically the service life you're going to get. 10 years for opaque coatings, that's paints. And, in Hobart on a north-facing wall, you're likely to just get about 10 years of any colour that's above a very pale one. You'll get a longer life with a pale colour than you will with a dark one. I've just had to repaint windows in my house that were done 12 years ago. The original colour scheme was purple. They expose to the northern light quite regularly during the day, and their paints all come off. So we'll put a white one back on, and the white paint is likely to last about 15 years, I expect. So significantly longer. Repair and replace. Now, when we first started to put together the information for this seminar, is that one of the key things we came up with was this whole issue of deck failures. So the news, report from the Building Commission about inspections saying that there's numerous rotting balconies that could cause severe injuries. And then here's one where you've got an example of a deck that's collapsed. You've got rot in the posts, you've got the material also then pulling away from the side of the building. This is another one. This is from a coroner's report in Queensland, where a woman in a house, probably built in the 1920s, has had something like 25 of her friends over and they're all parents of kids going to a particular school, and the kids were graduating from that primary school. Had them all over for morning tea to celebrate this. They all move out onto the deck. The beam at the front moves marginally. The only connection between the joists and the beam at the front were nails back in 1920. Water goes in, the nails corrode away. So the beam is slowly working its way out, and then when all these people come out onto the deck all at once, then the deck collapses and there's 2 deaths. So this is then, these sorts of occurrences are happening in almost every state. Here's another one, where again you've got localised decay problems. In this particular case, this downpipe and the post were leading to water getting through the top of the deck down into the wall that's in here, and that was what was supporting the beam. That the end of the beam and the wall rotted out, and then families having a function and the whole corner collapses. So these sorts of things can become are quite common, not common, but they're catastrophic when they occur. And all the state governments have been looking to ways in which they can increase understanding of this. So here are some observed problems that have been listed. One is pooling of water on the balconies or the deck surface. Balustrades that are fixed to the balconies or the deck's top surface and not fixed directly to the structure. And of course that's leading to wire balusters becoming loose because the deck moves and it can't resist the strain that will go onto those handrails. The tops of solid balusters and balustrades fixed at wall junctions can be loose or inadequate so that the handrail comes off the side. Cladding that finishes hard against the balcony of the deck, which then contributes to wet rot. So effectively, where the cladding comes down onto the deck and to the support of the deck and then directs water into that connection on a regular basis, so it can lead then to rot in the timber and additional corrosion then of the fixings. So as I mentioned earlier, if you can actually get a space between the cladding going all the way through and then a space, even just a 5 or 6 millimetre space between the support line, the supporting element, so you do have an air path through there and the cladding runs past, is that you will ensure then that everything there gets a bit of air through it and that you can inspect it properly, which is another one. Cladding and lining boards preventing visual inspection, so you can't see the problem until the things break. And also beams then that span long distances without any supporting posts or columns. The previous one obviously was where you didn't get where you have that rebate into the edge beam, and where you don't get good and definite support of one element on another that you can then inspect and tie things down with properly. So all these sorts of housings, discrete things, are things we're going to try and avoid. This is a list again from a guide from Fair Trading. Now, we've actually covered a lot of this stuff in the previous slides. We haven't covered insects because, again, we don't have them yet. Water and rot, though, is a persistent issue. Corrosive and coastal effects is something that we've mentioned, as is these extra heavy loads, which are causing problems because the loads applied in particular locations. If it's pot plants, you obviously get water around those locations more regularly than you will somewhere else. It reduces ventilation, etc., as well as overloading that particular location. So if you see people and you notice that there's these large extra loads going on to things, particularly if it's a renovation project or you've been asked to do an inspection, then these are the things you need to look for. There was in the break a question brought up about another undesirable detail, very common in 1960s, 70s and 80s buildings, particularly 60s and 70s, of making the floor beams, the large floor joist, span out and make the deck. Right, very common in Sydney, very common in parts of Tasmania too, where people would have a hardwood joist extended out, a 300mm one and span it out 900 and form a deck at the same time. Now the thing with all of those is that the outside pieces rot away and that brings moisture inside the building. It means is that your joists go as well as the deck itself starts to rot out. So if you see applications like that, there's very little you can do outside of putting a completely impervious deck over the top to make it watershed. So you basically bring those beams inside, or you cut them off if they're badly damaged already. You cut them off and you actually build a new deck that's structurally separate from the existing structure, because they are going to lead to the whole building becoming unserviceable. So for stairs and handrails, you want to check for signs of rot, corrosion, looseness. Stairs and balusters securely fixed, signs of sagging, loss of tightness. The thing about elements being fully bearing and secured is something that's regularly put through in all these guides, so that you do have solid bearing one on t'other. Check for signs of decay, rot and insect attack. You can, with a sharpened screwdriver or an awl or some other sharp pointed object, find where timber will be soft in particular connections. So if you're doing inspections, if you suspect something's rotten, you can do that to determine what it's like. And it will come in and come away quite easily. It's pretty mundane inspection process, but it's a reasonably effective one. You want to see if the timber needs a reapplication of stains, oils or paints. And you then want to check all connections for signs of deterioration, such as beams to post connections or any loose or rusting fixings. The closer and closer you get to an industrial area or to the ocean, the more and more you're going to get corrosion in the fixings. Particularly sheet metal ones, any that are exposed then to the wind and to spray. And then you want to check for any loose decking boards or flooring. I don't know if I've got much more. No, I haven't. So we may not have needed a break. We did.